Hello guys and welcome back to my YouTube channel. Today we will be discussing VLANs or virtual local area network, right? What are VLANs? So a VLAN, virtual local area network, logically groups devices into separate networks regardless of physical location. So it divides one physical location into multiple smaller logical groups or isolated networks. Devices in different VLANs cannot communicate unless explicitly allowed. For example, your guest wouldn't be allowed to communicate with HR, admin, IT, or anything like that unless explicitly configured, which shouldn't be able to anyways, but it's besides the point, right? It simplifies administration and enhances network flexibility. Why do we have VLANs? Breaks up larger networks into smaller, isolated networks for better organization. It limits communication between devices, protecting sensitive data, and it minimizes broadcast traffic, improving network performance. This is a VLAN diagram, all right? So this could be VLAN 10, VLAN 20, and VLAN 30, right? It operates on layer 2 of the OSI model, right here, data link layer. All right, and broadcast domain. This is mainly one of the reasons that VLANs are actually used for. So a broadcast domain is a network segment where broadcast traffic is received by all devices. It operates on layer 2 and it's segmented with VLANs, right? And it limits the size, reducing the size of a broadcast domain, improves network performance by minimizing unnecessary traffic. For example, let's say this is a broadcast domain, right? All of these are one broadcast domain. So let's say this computer over here needs to send information to this one here. It will send it to the switch, and because it's, let's just say it's unknown or unknown unicast frame, it's gonna forward it out of all the interfaces except the one that it received it out. So it's gonna go through here, 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 and that's gonna cause congestion because they'll have to say, no, that's not me, no, that's not me, no, that's not me, yes, that's me. I'm gonna send you another message for you to forward it to here. No, that's not me, no, that's not me. And here it wouldn't be that much of an issue, but on larger scale networks with like hundreds of users, that could cause a lot of issue, as well as just maybe overload the switch, things like that, right? An example of a broadcast domain is like, remember in school when there would be a specific group of kids that would be talking and then the teacher would eventually just yell at them, but everybody, even though it's specifically meant for these people here, the whole class would get yelled at, even though it's supposed to be just for him, right? And that's basically what a broadcast domain is. It's, if it's unknown, it's going to get yelled at to everyone regardless of what they're doing, what they are, what computer they are, right? It's basically like an example or an analogy of a broadcast domain. And then this is a segmented broadcast domain using VLANs. So again, the example, this is one, this is another one, this is another one. So let's say the same example. The teacher, or these kids are talking, right? And the teacher is going to yell, which is the teacher in this scenario would be the switch. So the switches, let's say this one's trying to communicate with these. Since they're using VLANs, this one would go here to the switch, and instead of yelling it to everyone, the switch would only send it to the teacher. Would be like, oh, you two, come with me, right? And then we'll actually go later into it because it uses .1q tags. We'll explain that later. But yeah, it's gonna send it specifically for these right here, right? Instead of yelling it out to everyone, it's gonna be like, you two, come with me, let's go talk outside, all right? What layer in the OSI model are VLANs? They are in layer 2. VLANs work in the data link layer of the OSI model, focusing on MAC addresses for communications. Broadcast domains. VLANs split up a single layer 2 switch into multiple broadcast domains, ensuring that traffic stays isolated within each VLAN. And VLAN tagging. Switches use protocols like 802.1q to tag frames, identifying which VLAN the traffic belongs to. No routing required. The devices in the same VLAN communicate directly without needing a router, as it's all layer 2 communication. And 802.1q, or .1q for short. It is a standard for VLAN tagging and Ethernet networks, allowing traffic from multiple VLANs to share the same physical link. It adds a VLAN tag, 4 bytes, to the Ethernet frame, identifying the VLAN the frame belongs to. It's like, oh, this belongs to VLAN 20. You send it to them. A trunk port transmits tag traffic between multiple VLANs, right? So it allows traffic from multiple VLANs to be carried over one singular link. The native VLAN is untagged, meaning it's not going to have this .1q. Where is this VLAN tag right here? This 4 byte. It's not going to have that, right? Because it's native. And then it would be right. I'm pretty sure it'd be right after length here. Let's see. VLAN tagging. Again, it defines which VLAN it belongs to. Trunks carry multiple traffic from multiple VLANs. Yeah, see? Right after the length. 4 bytes after the length, right? Excuse me, 4 bytes right after the length, right? In the layer 2, the data traverses this layer called frames. Here is what the frame looks like. This is the frame, the preamble, source, destination length, the .1q tag, and then the data. And then to actually configure VLANs, you do VLAN ID, and then you can type in name followed by the name of the VLAN that you want to give it. And then you can go into interface range or interface configuration mode, configure it as an access port, and then actually assign it to that VLAN. And to configure it as a trunk, in Cisco, it doesn't actually make you do this, but you would have to set the encapsulation first. So switch port trunk encapsulation, either .1q, which is the industry standard, or ISL, Cisco proprietary, not widely used, right? And then you do switch port mode trunk, and then trunking, and then it will start trunking, excuse me, right? And then you can use show VLAN brief to actually see what ports are assigned to which VLANs as well. And the access port only allows traffic from a singular VLAN to cross over that specific link and also assigns it to that, right? So access ports are used to switch ports that connect to end devices such as PCs, printers that belong to, again, a single VLAN, keyword single. Each access port is configured to carry traffic for a specific VLAN only one. Ideal for edge devices that don't need to communicate with multiple VLANs. Frames arriving and leaving on an access port are untagged. VLAN tagging is only used internally within the switch. And this is an example of access ports. As you can see, this is the 1 VLAN, 2, and 3. And trunking, right? Trunk ports are switch ports configured to carry traffic for multiple VLANs between switches or between switches and a router. Frames on a trunk are tagged with VLAN IDs or .1q tags to identify the VLANs that they belong to. The native VLAN again is untagged, and let's show you. So it's one physical interface, but it's logically broken up into trunking, allowing traffic from multiple VLANs to actually carry out. See, red is 30, purple is 20, green is 10, right? So these are access ports, and this one is trunk. Again, this is only one physical interface, right, or physical link. Again, this is trunk, this is access ports. And then we'll actually go into a lab, like I'll show you on Packet Tracer how to actually do it. We'll do router on a stick, as well as using a layer 3 switch as well. Native LAN, the default native LAN is 1. That's where all devices are defaultly set to. And on most switches, and it's going to be untagged again. Native LAN is always going to be untagged. Frames sent with out of LAN tag are automatically assigned to the native LAN. The security risk is since a security risk is since all native LANs are default 1. Attackers may try to exploit that since everything on LAN 1 is untagged and that's the default setting. So it's best practice to change it to an unused LAN, a random unused LAN, right? A key rule is avoid using LAN 1 for production traffic to enhance network security and management. And this would be the output of show VLAN brief. Actually, I think this is show VLAN. Show VLAN brief would only have like this part right here. So from this 1005 and up. This is show VLAN, right? VLANs and subnets. So VLANs are separate broadcast VLANs are separate broadcast domains, so devices in different VLANs cannot communicate directly, even within the same subnet. Inter-VLAN routing, a layer 3 device, like a layer 3 switch or a router, or a layer 3 switch with IP routing enabled, will be able to actually do inter-VLAN routing. For communication between VLANs and routing requires distinct subnets. Using the same subnet across VLANs can cause duplicate IP addresses and routing errors. They require unique subnets for each VLAN to make network configuration, troubleshooting, and policy enforcement easier. And then this is inter-VLAN routing. I'll actually show you this as well. So inter-VLAN routing allows communication between devices in different VLANs using a layer 3 device. How it works, traffic from one VLAN is routed to another via a router or a layer 3 switch. Each VLAN is assigned to a unique subnet for routing. Again, we'll show you router on a stick using sub-interfaces on a router, as well as a layer 3 switch using SVIs for VLAN routing, or switch virtual interface. We'll do this in a bit. Let me just show you this. Sub-interfaces are logical divisions of one physical link. So it's kind of like, for lack of better words, like schizophrenia. So your eyes are telling you it's one link, but in your mind, there's can be, for example, this one, yeah. So in your mind, you see this is one link, a singular physical link that you can physically see with your eyes. But in your mind, there's sub interfaces. There's three sub inter. No, for here there's two actually. So two sub interfaces, excuse me, right on this. So even though even though your eyes tell you it's one, your mind is telling you it's two, right? For lack of just having an analogy, right? Use cases, right? Set logical division, allowing the same interface to handle multiple VLANs or networks. Commonly used for router on a stick. We'll configure that in a bit. VLAN tagging. Each sub-interface is associated with a specific VLAN using encapsulation.1q command. I'll show you that as well. And they require unique IP addresses. Excuse me. Each sub-interface has its own IP address, acting as the default gateway for the corresponding VLAN. All right, and that's pretty much it. Let's do router on a stick, or which one would be? They're pretty much the same thing. So let's just do. Let's just build them both, and then we'll show you. So let's just get like 3 end devices. Here, this one's the router on a stick that we're gonna do here. We'll do router on a stick first, and then we'll also show you using SVIs. So let's just, I'm gonna color code the VLANs first. Which is 1, 2, and 3. Now let's connect them. And remember, they have to be unique subnets, not the same one, because then that just causes issues later on. Make it look a little centered, make it look pretty. Move this a little closer and down. This one should be, I think right there should be fine. And then should be good. And then for now, I'm gonna do, there's 3. So we'll do, I'll show you the sub interfaces. Hopefully I choose the right colors. Let's do, is that? No. Do this. It's not coming out outline. Oh, excuse me. Yes. Just say this is the sub interface. This is not. This is the sub interface that I was talking to you about. Let's see. I think it's this one. This is just for you to get like a better understanding of it. And then hopefully it fits. This one's going to be a really skinny sub interface. Perfect. All right. And then we will name this LAN 10 192.168.1.0/24 LAN 20 192.2.0/24 and LAN 30 192.168.3.0/24. That should be fine. It's here. Here we will do pretty much the same thing. We'll just sub interfaces. So LAN 10. I'm just doing this as the default gateways that we're going to put, or the IP addresses that we're going to put on the sub interfaces. And that's good. All right, let's actually get to configuring. We'll use the second available IP address on these. We'll do 192.168.0.1. Copy. We'll just paste this here. Change that. Subnet. Close it actually. Same thing here. Let's change this to the 2. Copy this. Fast Ethernet. Change this to 2. Subnet. Perfect. Go to here. Configure. Change this to 3. And typically, router on a stick wouldn't really be used simply due to the fact that it could have bottlenecks. Like for example, this could cause a lot of congestion. Even though it's only 3 here, like it's used for like smaller networks, this wouldn't be an issue this. But if you, let's say we have 50, would you really want to have it go from here to the switch to here to here? Like that would cause bottlenecks, right? So in larger networks, I'll actually show you they'll use layer 3 switches and SBIs for inter-VLAN routing rather than routers on a stick. So let's actually, we've done that. Let's go into the switch here and actually start configuring things. So first we'll actually start by making the VLANs themselves. And conf t LAN 10. We'll name it, we'll put the name here. We'll put, I guess, IT, name this HR, HR, name this admin, name, IT, we'll do exit, and then we'll do LAN 20, main, HR, and that's pretty much it. You're just creating the VLAN, put VLAN followed by the VLAN ID or the number that you want to put it, and then these are the ranges, right? So we'll do 30, and then the name command, while you're in VLAN configuration mode, just do that. We'll name it admin, exit to back in global config mode, and then we'll assign them. So let's actually enable this really quickly. Perfect. Let's move this here. All right. Let's do LAN 10 IT first. So we'll do interface, fast Ethernet 01, switch port mode access, switch port access LAN 10. right? And then I'll actually show you the VLAN brief and that the ports are actually assigned to the appropriate VLAN as well, right? So we'll do exit interface fast Ethernet 02, switch port mode access, switch port access LAN 20. And as you can see, I'm only typing like a few letters. It's because if you click tab, it actually auto like completes it for you. So you can do like I'll actually show you without doing tab how it's able to process the commands with only like a few letters, right? Do exit interface Ethernet 03 switch port mode access. See, like it's able to actually process switch port mode access just with SWMA. And then I'll continue tabbing so you can actually see the full command just so you can get a better understanding and just practicing it and hearing it and understanding the actual commands, okay? And 30, right, do exit and then show or do show VLAN brief. And then this is the VLAN brief. So it's the IT, HR, and admin have been created, 10, 20, and 30. And then it's also going to show you the interfaces that have been assigned to those VLANs specifically, right? And then again, this is the native LAN, default one. But for now, that's pretty much it on the layer 2 switch. Now we have to actually configure the sub interfaces and default gateways on this router here. Let's go ahead and do that. Actually, this one's not so good. Let me here. This table. Perfect. All right. So wait for it to boot up a little. No. And conf T. So first, when we're doing router on a stick, we have to make sure that the interface is physically up, the physical interface that we're using. Remember how I said it's kind of like schizophrenia? The physical interface that you're physically seeing has to be up. So this G0, G0/0/0 has to be physically up first before we actually do any configurations on the sub interface. And just to show you, do show IP interface brief. So see how they're all administratively down. So we'll go into interface configuration mode. Do no shut. Now it's physically up. We can exit it. And the way to actually get into sub interface configuration mode is doing sub interface followed by the interface and the interface that you're going to use for the sub interfaces being gigabit Ethernet 0/0/0. We'll do dot and then you can do the interface number. Typically, good practice is assigning it to the appropriate VLAN, right? Regardless if it's 10, 20, 100, 99, etc., right? So it's the best practice just to have the sub interface match the VLAN that it's supposed to be supporting. So we'll do that, and then look, it tells you line protocol changed to up. So we've created the sub interface. If we do show IP interface brief, you can see it being created right there, right? So, and then another thing, you'll do this, we'll do encapsulation, and then .1q, and then 10. So this is the IEEE 802.VLAN ID tag. So this subinterface 0.10 is going to be specifically used for VLAN 10 traffic. So that's what this encapsulation .10 command does. It assigns that subinterface to that specific VLAN to carry traffic only from that VLAN, okay? So we'll do enter. Now we will be able to add an IP address because I'll actually show you on the next one when we do VLAN 20. Do 192.168.1.1. I assigned this one 2, just checking really quick. Yeah, 2. All right, perfect. 2. Exit, do show IP interface brief, just to show you. it has an IP address now. Again, we'll do interface. Actually, let's just do up. And this will just have to change the 20. Whoops. Change the 20. So that's going to be the VLAN 20, just best practice, right? It's going to create it and put it to up. So now I'll show you, even if you try to add the IP address, it shouldn't allow you to, just because we haven't assigned it to a specific VLAN. See? Configure IP routing on a LAN interface only allowed if that sub interface is already configured as part of the 802.1q or ISL LAN. So we have to set the encapsulation first, right? So encapsulation.1q, and we'll do 20. So specifically, LAN 20 traffic on this sub interface here, okay? Exit. We'll do the same thing, just up. It's going to create it and put it in the up state. Then we'll do IP add. Actually, no, remember, you have to set the encapsulation first. .q 30. And then that's pretty much it for the commands. Let me just show you do show IP interface brief, and it's going to show you the actual sub interfaces that we've created and that they're in the up state. Now I'll ping test just to confirm Inter-VLAN routing, and then we'll do it in simulation mode to show you how traffic actually traverses or goes through the network, basically, right? How it goes transverses the network. There you go. Ping 192.168.3.2. So we're pinging from IT to admin. So we'll do simulation here. We'll do here, ping, ping. And then it's going to go from the switch through the sub interface of 10. That's strange. Did I configure this as the 2? I did. So what is missing? Assign these to access ports and created the VLANs. So let's see again to see if we're able to actually get a message or troubleshoot it. So ping is always going to be an amazing way to So that should be about it though, that's the thing. Show IP, show run. That should be about it though. Like we've created the VLANs, assigned them to the appropriate access port. Oh, I see why. We forgot an important part, and it's just configuring this fast Ethernet 04 as a trunk. Remember, trunks allow traffic from multiple VLANs to actually go over a single physical link. So let's go ahead and do that. My fault, guys. Switch port mode trunk, and now it should be able to. Just to show you, do show interfaces trunk. Boom. All right, now let me show you the actual commands, or the actual pinging and how it transverses the network. Sorry about that. Now it's going to go to the router. The router is going to send it again. It was through this blue sub interface. Now it's going to go to this pink one, or whatever color you want to call that. This is STP. STP is not what we're doing using ICMP. Let's actually fast forward. The pinks should have gone through either way. We did everything already as well. See, it's going through. I'll show you again. Actually, using simulation mode, hopefully it shows the traffic actually transversing the network instead of it doing STP. So again, it's going to go to the router first. The router is then going to send it from this blue subinterface, or that belongs to VLAN 10, to this pink one right here that belongs to admin. Send that back down. The switch now sees the tag, the .1Q tag, and sends it here to 30. Boom. Now it goes back to the switch, still on VLAN 30. Goes to the router, sees it's in VLAN 30. Now can send it down to VLAN 10 using that VLAN 10 interface. And boom. But yeah, that's pretty much it for router on a stick. Not really like useful in large networks. So we'll show you the layer 3 switchway using SVIs. So here it's mainly used in larger networks, simply so it doesn't have to actually go to the router before exiting the network. And just do it like this as well. Green. We'll do purple. And we'll do this color here. Alright, now let's get connecting them. Whoops. Tedious part. Actually, we really don't need that router. This is pretty much all you need for Inter-VLAN routing using a layer 3 switch. So let's actually get into it. We'll use the same IP address scheme. Same thing here. And we'll pretty much just copy it again. Let me just get all of these just sorted out just to make it easier to visually see and understand. Almost done. And then we'll actually get into configuring them. Whoops. Go back and do that. Let's just change this to 3. Admin 30 all copy. Alright, let's go into the CLI of these layer 3 of the layer 3 switch. Move that here. No. And conf t will assign them to interfaces, or the VLANs, excuse me. Interface fast ethernet 01, switch port access, switch port access VLAN 10. You can also just do it like that without creating the VLANs first, but let me create the VLANs first. Name HR 30, excuse me, exit VLAN 30, name admin, exit interface VLAN 10, name IT, exit. We'll do interface class Ethernet 02, switch port mode access, switch port access 20, exit, fast Ethernet 03, switch port mode access, switch port access VLAN 30, exit, and then now let's create the actual SVIs, or switch virtual interfaces, right? So we'll do interface VLAN 10. It's going to change it to up. We'll do IP add 92.168.1.1, and then we'll do the subnet mask. No should. Exit. Again, we'll do interface VLAN 20. It's like adding an interface and then followed by the interface ID. It's just using a VLAN followed by the VLAN ID, right? 20, IP add. Exit, and then interface VLAN 30. And then exit. And then we'll actually configure this with the appropriate information. Assign this the second one. Whoops. 3. Perfect. Now, if we were to ping, would you think that it would work? Let's see. Hopefully you have your answers locked in. Ping 192.168.3.2. And the pings, let's see if you were right, should fail. Why? Because currently this is still a layer 2 switch. We haven't enabled the layer 3 capabilities yet. The layer 3 switch has 2 layer 3 capabilities. It's able to actually have a routing table and, build a routing table and learn routes. And the other one is it's allowed to actually have an IP address on the interface instead of using a switch virtual interface, right? And we enable the routing table one, which is necessary for Inter-VLAN routing by typing in global config mode, IP routing. And that's it. Now the ping itself should work. And then we'll actually show you it in simulation mode once this ping goes through. That's ARP, perfect. Now it's actually performing Inter-VLAN routing without having to send it via to the router first and then handle it again through the switch, right? So it's handling everything locally. So let's go ahead and ping one more time. Simulation, do this, and then we'll show you how it handles it. Right? And then I'll show you it next to each other. So we'll do ping again, we'll do ping here, we'll do simulation, this, this, whoops, this, scroll over a little again, this, we will minimize this and show you them side by side how they look, right? See, boom. So it's gonna go to the switch, but this one's gonna have another step in actually sending it to the router, while this layer 3 switch can do the routing or the Inter-VLAN routing locally. You see how much faster that is? So by the time this ping actually gets to the destination, this one has already completed the first bidirectional communication, right? Like if we go here, reply, right? If we go here, it's still waiting for that bidirectional communication. So it's just simply much faster and doesn't have that much bottlenecks. Like this one should be done already. Let me see. Well, almost. It has two. Well, this one has one, right? So it's the using SVIs and layer 3 switches is much faster and better for larger networks. Well, this one causes bottlenecks when more end devices are actually there, right? But yeah, that's pretty much it all for today, folks. Thank you for tuning in, and I hope you enjoyed the video. See you in the next one.